can be easy. And I make it my challenge today to actually tell you how this can be, that it is easy. And we will go through a few steps of what you actually need to do to make it easy. And what you need to do to monitor OpenStack in the first place. So I've been here last year, I enjoyed the conference as well. Who has been last year as well? A few people, okay. So the topic of last year basically was, is OpenStack production ready? And should I really use it? And I think this question has been answered positively throughout the community and through all companies. And a lot of companies actually picked up on OpenStack, started using it. And yeah, so I'm going to tell you what full stack monitoring actually means for us. Someone is playing with the sound. So what is the difference between an OpenStack cloud, running applications in the OpenStack cloud, or running your applications in a public cloud? Let's take AWS for example. You deploy your applications there, and you more or less just hope that everything goes fine. All that you get are instances. That's like the tip of the iceberg. What is below that tip of the iceberg? You don't know. Okay, you know that there is some hardware at some point, but then again, you just don't care. You pay that it just works. On OpenStack, this is like almost similar story. As a user, you deploy your applications on your cloud platform. But on the contrary to AWS, at least the OpenStack administrators exactly know what's going on under the hood in your cloud platform. They actually need to know, but because they set it up and they need to maintain it, to operate it. And they know that there are some of these OpenStack core services around. And they know that there are some supporting services around that actually make the cloud platform functionality happen. So what I would like to do today is actually to go through an example, to give you a feeling of what full stack monitoring actually could mean when running applications on your OpenStack infrastructure. So what this picture shows is like a visual representation of different application components. So each of these icons represents either a service, a VM, this is an OpenStack compute node, and there is a MongoDB, and on the top, where the user icons are, these are like user-facing applications. These are real web front ends where your end users can interact. So on the one hand, this is like, so it's called Easy Travel. It's like a travel agency web page. And the other web application is a business-to-business platform where other travel agencies can do business with you and do payments and stuff like that. So if you actually look at this application, there are more or less 3 layers to it, and I don't talk about typical 3-tier applications. Now on the top you actually have your end users. If you're a company and you run your applications, what you're ultimately trying to do is generate revenue or provide some sort of service to some sort of end customer. It's the same story if you are a public cloud provider. What you are doing then is you just provide, I don't know, for example, Horizon to your customers. They use that to deploy their applications. In the end, it's all about user experience. If the users are not satisfied with the quality and performance of your product, they're just going to switch back to AWS, for example. Or if you run your e-commerce shop on your OpenStack platform and the performance just sucks because your checkout process takes like 14 seconds, everyone's just going to go to Amazon and buy there. That is why it's important. At least your CFO cares. And your CFO will make you care. Then I've been hearing that over the last few years, all around the different events around the world, cloud is all about applications. So at one point in time, the cloud platform should just be there and we should all focus on the applications again, because that is where the money is made. That is where you make your users successful, and that is where you make your end users happy again. So yes, of course. Then again, you need a cloud platform. And that is actually where OpenStack comes into place, at least in this example. And I think there is no doubt that you need to monitor the user experience of your customers, because otherwise you wouldn't even know if you have high bounce rates, or if your customers just leave your web page because the checkout process takes so long. On the other hand, there is no doubt that you need to monitor your applications, because otherwise you can't find out why the checkout process takes so long. And finally, if you run a private cloud platform based on OpenStack, you definitely need to monitor your cloud platform. You need to monitor OpenStack, its services, its performance. So you need to monitor your OpenStack services. We actually said that right now. And what you want to know about your OpenStack services is actually, is it performing well? Is it performing well consistently? Is it using up too many resources? Is the response time okay? Or is it increasing? Or is it even decreasing? And if so, why? And there's, of course, the portion of the log files that we will get to in a few seconds. Besides the services, there are the supporting services, the message queues, the databases that store the configuration data of your cloud platform. And memcached, for example, which is the component that actually caches keystone tokens. That keystone consumption goes down. These are all supporting services that make your cloud platform work and that you need to take care of and that you need to know about. You need to know if they're healthy or not. The next thing, and I actually had 2 or 3 discussions about specifically that topic today, it's about resource capacity and utilization. Do I have enough processing power in my cloud platform left? Do I need to buy additional servers? Did I construct my flavors in a smart way? Or is it like that the memory is out on each compute node, but the CPU is at 10%? It's probably important information also for capacity planning reasons. And then, of course, there's log analytics. So who is an operator of OpenStack? Who has actually once troubleshooted an issue in OpenStack? A few. Perfect. So I bet at one time, at least for me, it was like that. So I started a new instance on OpenStack, couldn't get any network connectivity, and I looked Stack Overflow, and it says, look at the log files. I said, yeah, okay, log files, perfect. Entered SSH into the box, went to var log, and looked for the log file. And I was like, holy shit, there are like 300 log files. Each log file is on its own log rotation, so you have to be really lucky that you find the correct log file you need to look into right now to find the culprit of the issue that you had an hour before, because that's already the time you wasted tracking down the log files. So log analytics is one of the crucial parts of OpenStack monitoring, because, well, that's the nature of OpenStack. It's based heavily on log files. Then we said cloud is all about applications, so you want to monitor the response time of your applications, if it's steady or not, if your databases are performing properly or not. That is also part of the equation. And of course, the end user experience. So are like the users out of Bolivia that use Chrome 29, do they have a specific problem? Are they part of your target group? It would be the next question. Do you even care? And just like being able to revisit the user sessions of your end users of your application is important. So we now already covered a lot of data sources. So metrics of services, metrics of application, metrics of supporting services, log files. These are like a really large amount of data. If you ever have configured OpenStack and operated it and deployed an application on it, it's like a huge amount of data. So the one thing that you would actually need to do to make sense out of all this data, you need to correlate it. And correlation is this nice statistical feature that measures indicate the extent to which 2 or more variables fluctuate. So that sounds funny, so I have a funny example for that. The amount of beer you drink correlates to how drunk you are. If you don't trust me, just try it at the welcome reception, drink 8 beers, I guarantee you you're drunk. And there's not only a correlation between those 2 things, there's also a causation behind it. So you could actually argue that you're drunk because you drank the 8 beers, but yeah. Enough with the funny examples, let's go to an example out of an application. The title of the slide says correlation doesn't imply causation. Let's take this example. You have a service that is providing some data to whatever other service or other web front end you have. And the response time of this service increases by 2 seconds. You don't know why, it just does. And, sorry, just assume for a second that you have a magical monitoring tool that actually tells you that. Just bear with me. On the other hand, your magical monitoring tool tells you you have a host where the CPU utilization is above 90%. And those two things happen at the same time. So the logical conclusion would be, of course, the service response time increased because the CPU time is over 90%. I mean, it's a no-brainer, right? The thing is, it's not, right? Just because two things happen at the same time does not necessarily mean that they have anything to do with each other. So in addition to all of this data and log files and measurement points we have, you also need to know about the architecture of your applications. You need to know which application component talks to which component, which host hosts which processes and services and end-user applications. Because it could actually be like that you have a totally different application where the response time increases, and a totally different host where the CPU utilization is high, and they don't have anything to do with together. So, as you see, it's not a trivial thing to monitor or troubleshoot applications as it is. Running them on OpenStack doesn't make it easier. So, let's go back to that example. You're now familiar with the terminology and what the icons mean. We have the web front ends on top, the application components in the middle, and the OpenStack components, your virtual machines, instances, and the compute node on the bottom. And there's actually a funny thing that happened. We once had an intern, his name was Danny, and Danny was fresh from college. He thought he could change the world with 5 lines of code, tried to reinvent the wheel, everything he programmed something. And his first task was actually to fix a bug in this service. I'm not sure if you can read it, it's called payment service. And he got the bug, and he just programmed and fixed the bug and committed his patch. And this is what happened. Again, our monitoring tool tells us the response time increased for the payment service. And of course, we know that it's because of the commit of Danny. But it's very important to actually be aware of that. And funny things started to happen from here on, so please pay attention. Let's phase out the OpenStack component on the bottom for a brief moment, just to make it more dramatic. What happened a few seconds later, a few minutes later? The application over here, so not the application of the payment service, the other application actually slowed down. And this actually had an effect on the end users. So the end users weren't able to book their journeys anymore, weren't able to look up target destinations or the weather, how it is in Cairo. So basically, the company was losing revenue because the users weren't able to interact with the services that they actually provide and generate the revenue. And our magical monitoring solution actually told us, okay, this is slow because the service below is slow. And this is slow because the booking service is slow. Also, this service is slow. And also, the whole backend service is slow. So at first glance, this actually looks like 2 different problems. But the funny thing is, actually, due to the bug that Danny introduced in the payment service, the CPU utilization of this virtual machine spiked high. And this actually had the effect that the overall CPU utilization of the compute node spiked as well. And that eventually had the effect that the other virtual machine was also affected. So basically what Danny did, he fixed the bug in this service and managed to screw up a totally different application over there without even knowing it. Now, think about that. If you don't have a monitoring solution in place, how long would it take you to figure that out? Come again? You won't, right? It won't. Probably you would have shut down already because you're not having up your end user service anymore. So this is actually a very, I like this example very much because it really happened. So putting it all together now, we talked about measurement points and what you need to take care of. So with large environments, large application environments, I think I made it clear right now that manual introspection and manual hunt down of like root causes doesn't cut it anymore because it's just becoming too complex. Just the 100 log files of OpenStack alone is enough complexity. So we talked about OpenStack service availability and performance. We talked about the supporting services, resource capacity and planning, log analytics, the applications that are running on top. We just had a perfect example of that. Usually your applications run in some sort of PaaS, so OpenShift Cloud Foundry or something, so just adding complexity on top of that again. Then you have the real user monitoring, where you actually figure out if your users are satisfied with the service you're offering. Then you have to correlate all of this. And on top, to be able to actually do root cause analysis, know about all of the dependencies in your application environment. So this is not an easy task. And another important thing is actually if you only do like 3 of those. So let's say you focus on log monitoring. Then you have the log analytics, and maybe you have some small portion of information that is available from the other issues. Anyhow, you're going to have blind spots. And I like this graphic very much, and because in the Netherlands, everyone is riding a bike, and I really like that because I also like riding bikes. And the funny information here is that actually the truck driver does not see anything that's within this yellow lines. So for me as a biker, this is very important information because you just know if you drive in any of those areas, he doesn't see you. He just runs over you. So with the monitoring approach, it's not like dead or alive, but still you're going to have blind spots and you're going to miss very important things if you don't focus on the right ones. And after all, this is not a regular size application environment. This was like a demo application, a small part of a larger application. Your applications don't exist out of 3 hosts, 10 services, and 2 applications. What we at Dynatrace usually see are applications like that, where you have 3,000 services, 10,000 processes, 142 hosts, 7 different data centers, which could be OpenStack, Azure, AWS, which makes it not easier to actually do root cause analysis and monitoring in those environments. So there are open source monitoring solutions out there. Of course there are. You could do system resource utilization monitoring with Nagios or Isinger. You can do log monitoring with the Elk Stack or Elastic, the Elastic Stack, it's now called. You can do that, but usually you have like siloed information pools. In the end, you would have to do the correlation all on your own again. You have some information there, some information over here, and actually you need it here. And you need to pull it together on your own. So if you are actually going on a journey to OpenStack or migrating to OpenStack, starting to OpenStack, I would really encourage you to think about monitoring and troubleshooting and operations up front. Make a conscious decision if you want to go in with a small army of with a specific feature, or if you want to tackle the topic of troubleshooting and monitoring with a whole fleet. And there are 37 submarines in this picture, and you can't see them. So the thing I'm actually trying to say, you all need to do that if you want to successfully operate, troubleshoot, and monitor an OpenStack environment. And of course, the applications that are running on top. And we at Dynatrace actually provide a solution that has you covered on all that ends. So I don't know how many of you visited Marcus' presentation in the slot earlier. He told a lot more about Dynatrace. I focused more on the technical part. But anyhow, so now is my introduction. So my name is Dirk. I work at Dynatrace, technology lead for OpenStack and SDN. If you have any questions and you don't find me after the talk at the booth or at the welcome reception holding a beer and trying to figure out if it's really true that you get drunk when you drink beer, you can either, so here's my Twitter handle, here is my email address, just reach out to me if you have any questions about the presentation, about Dynatrace, about what we do with OpenStack. Please feel free to do so. And with that, my last slide won't come. Okay, here it is. Bedankt. Thanks. Wow. Are there any questions that we could answer right now? Yeah.
You offer this as a service and as well to be available on premises, right?
Yes.
And what is the difference in pricing?
The difference in pricing? No difference. As I said, I'm the technical guy, the sales guy sits in the back. I had to check with him. So there's no difference. There's also no difference in functionality. So you get exactly the same feature set you get in our SaaS offering as you would get in your on-premise managed offering. Welcome. All right. I think we're on time. Are we on time? Perfect. Thank you very much again. Take care. Enjoy the rest of the event.